Welcome back, everybody. Today we're going to have a look at TEC Redshift Development Kit, which is the first challenge after you open the second dossier package. So let's jump straight into it. There is an unknown 3-digit code, such as 473, that when entered one digit at a time into pass will unlock the link. Okay, cool. Oh. Now, how it normally does in typical programming is X, Y, Z variables and just nest them, but we're not going to have that. We don't have that sort of flexibility because we don't have 3 variables we can really work with. I guess we kind of do X, T, and M, but it's hard because you can't write back into M easily. Actually, you probably could. Instead, we're going to have a look at a new function called swizzle, which we're going to use to mask out different parts, because all we need to do is iterate from 0 to 999 and pass it into the lock piece by piece. So to do that, we're going to link, and then we're going to create a new function called brute. And this is going to be our brute forcing function. Yes, I think. Maybe. Yeah. Okay, so X by default is going to be set to 0. So we can do it for this. So we're going to use Swizz. Now Swizzle will allow us to mask out certain parts of a register, and then pass that register information onto something. So it's pretty useful for this use case, because it means that if we have like 000, for example, and we wanted to get this 0 here on the left, we can just basically pass it 3, because it's the third position, and it will pass that to whatever we call. So we could call pass, and that means that, like, if we had a 1 there, for example, the value that gets passed to pass would be just 1 by itself. And that's what we want, because to unlock the lock, you have to pass each digit in 1 at a time. The other benefit of this is, even if we just have 0 with no characters here, for example, passing in 3 will still return 0 here, which is exactly the functionality we want, because from 0 to 10 we won't have any value in the hundreds field. So the swizzle operand helps out a lot with that. So it seems kind of simple, but we can actually do this. Swizz x2 pass, and then swizz x1 pass. However, now we do need to yeah, so then we'll jump to another function that we're going to define. We're going to call it test. Yeah, we're just going to call it test. I'm going to copy the x value into our communication line, because we're going to have a second exert handle checking to see if that value was indeed valid. We're going to mark a new loop, and we're going to copy the m value into our x register, and then we're going to create a new marker called try. And try is going to basically check to see if it can get into the locked container. So it's going to try to link. Will that work? For now, we might need to leave this blank. We'll just try it out and see if it works. Just going to find one that has like an easy code. So let me just revert back. Find a easy. Okay, that's an easy code. So that's 2. So we only need to make it 2 in for it to work. We'll just finish this loop off. Just jump back to loop. work. Oh, I need to need to increment. Okay, we'll jump back to brute. So this will just increment the x value and then pass the x value through. So this should on try 2. So when x is equal to 2, it should be now. Yep, it should pass in the 2 value. Yep, cool, and it's unlocked now. So now we want xb to basically test to see if he can get into 800. So we'll write that logic. Mark try, link 800, grab, and then the file was 199. Luckily that doesn't change. And then we're going to copy the we're going to copy the pass, the phrase, so we're going to copy the phrase out. Yeah, that's good. Try that, hold on. He did not walk in. Why did he not walk in? Ah, not calling try. So this is the problem. If I step into the room, or if I try to step into a room that doesn't exist, it will break my robot. So I can't just call try out, right? I have to replicate and then call try. So the effect this will have is the bot will replicate, it'll try to access lock room, it'll fail. However, when we get to number 2, the bot will be able to enter the room. It'll be able to pick up the data and then do nothing. But we only need to extract this this field here, this RDK, and then append it to the end. So let's go ahead and do that now. We also need to append the the data that we got from here as well. So let's do that to start with. So we've copied from the file to a temporary variable the ID that we need. So then we'll drop that file because we don't need it anymore, and we'll make a new file. At this point, we have the x value that we need to put into our file. So we can actually do, again, make use of the swizz command to pretty much just write out to file the data that we need, those 3 fields. And then we'll also copy from our t variable to the file the ID. And then we'll quickly get out of the room because our robot is no longer needed. So at this point we'll be back in the first room, so then we'll do a drop. I think that's everything we need. Let's have a look if it works on 2. He walks in, he reads, he creates a file, he then starts appending the code, yep. He appends the ID, and he leaves. Oh, more robots. Crap. Places it. Leave no trace though. Okay, so we need a way to clean up the mess we made. And these guys are still iterating, so I know what we'll do. I'm sorry, the children have to kill their parents. So we're going to link forward again. Yep, and then we're going to do a kill, and performing a kill on the parent will kill the child too, I think. So then I'll do a drop. Don't think I need to drop though. We'll see. Okay, so we step into the unlock room. We get out, we drop the file, we move into here, we kill, and then this other, okay, so we're relying on the other robot. to step into the room. And then kill. That's interesting. It's funny how this worked too. Because technically what we've done is we've dropped a file in there that isn't correct. But the game seems to allow that. Okay. Well, the tests are running, which is good, but that's an interesting side effect that it has not picked up, because I guess we didn't leave a trace, and there's no harm. Okay, cool. That worked pretty well. So yeah, I'll see you in the next one.